this question is an example of what you might see on the first free response question on the AP Precalculus exam. So we'll go through this together to get an idea, and then you're going to do question 1B for your homework. For this question, they give us a table for f of x up there at the top, and they tell us the domain of f consists of 5 real numbers, 1, 2, 3, 4, and 5. The table defines the function f for these values. The function g is given by g of x equals 0.35x to the third minus 3.5x squared plus 11. So the first thing that we're asked to do with these two functions is in part 1 of part A. It says the function h is defined by h of x equals g of f of x, and then they also give you g of f of x in different notation. We're supposed to find the value of h of 1 as a decimal approximation or indicate that it is not defined. So I am going to go over here and open up Desmos so that we can see this. And I'm going to type in my function g of x equals 0.35 x to the third minus 3.5 x to the second plus 11. So we have that in there. Let's make sure we've got everything right. So h is g of f of x. So over here, we want to show our work. So we're showing h of 1 is what they're asking us for. That's going to be g of f of 1. This is my preferred notation, that second notation there. You need to find f of 1 first. You're going to do that from the table. So whenever your input value is 1, your output value is 6 right here. So now this is going to be equal to g of 6. And if you already have g of x typed into Desmos, look how easy this is. You just type in g of 6, and it is going to give you the answer there. So we have negative 39.4. And this is calculator active, so that's all you have to write. You don't have to show any extra work for that, but you do need to write down these steps. You do not need to do this in your head and just write down the answer. Okay. If we move on, it says find all values of x for which f of x equals 4, or indicate that there are no such values. So if f of x equals 4, you're looking at the f of x line of this table, and you're looking for somewhere where x equals 4. It's f of x equals 4. That's going to actually happen twice here. So we can say f of x equals 4 at these two locations, and we're given the x coordinates where these happen. So x equals 2 and x equals 5. We're just pulling these from the table, so we don't have to give any more explanation than this either. That's going to be our answer for that part. All right, moving on, we are supposed to find all values of x as decimal approximations for which g of x equals 5, or indicate that there are no such values. So I would do this from the graph. We are looking for where g of x equals 5, and I would do this entirely from the graph here. So I'm going to go over here, pull up Desmos. I don't really need this g of 6 anymore. We'll zoom out a little bit so I can see my whole graph. If you type in, you could really type in g of x equals 5, but if you type in y equals 5, it is going to give you a horizontal line right there where your y coordinates are 5, and you have 3 answers to this problem. So you are going to say g of x equals 5 at x equals, and let's actually split screen this so I can see these all at once. We got negative 1.235. Keep at least 3 decimal places. If you want to keep more, that's fine. We also have x equals 1.413, and x equals, over here, we've got 9.822. And that's all that you have to do for that. You're just looking for those places where that g of x equation equals 5, which means its y coordinate is 5. Okay. We are also told to determine the end behavior of g, which is the graph that we have over here, as x increases without bound. And they tell us to express your answer using the mathematical notation of a limit. So the big thing is here that you cannot give left and right behavior here because they're only asking about x increases without bound. So that means that we're approaching positive infinity. So when you write the limit for this, you want to just do the limit as x approaches positive infinity of g of x. You don't have to give the equation, you can just write it this way. And that is just asking us what's happening to our y values as we go to the right. And as you can see here, you can zoom out to the right, our graph just goes up, 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 up forever towards positive infinity. So that's all they're looking for here. Do not give the limit notation for the left side. Don't talk about the limit as x approaches negative infinity. This question is not asking you that. That would be for whenever x decreases without bound. Okay, moving on. C says determine if an inverse function of f can be constructed for all values in the domain of f. So the key here is that it has to be an inverse function. Function is that key word right there. So if we look up here at this table, I've got different x values, 1, 2, 3, 4, 5. This table shows us a function. We have none of our x values are repeated. However, if we made a table for the inverse function, and I'm going to zoom out a little bit here so that I can see that. Actually, I'm going to do this. I'm going to screenshot that table and put it down here so I can show it in the screen. Alright, so this is my table for f of x. So that means that my table for f inverse would look like this. 6, 4, 0, negative 1, 4, and 1, 2, 3, 4, 5. The x and the y coordinates just switch. So if I look at this now, in a function, x values cannot repeat. Alright, so I can see that I've got a 4 that repeats here. So the answer to this question is no. An inverse function cannot be constructed for all values of f, for all values in the domain of f. Now, part C, when they grade this, they're really just grading it for whether you say yes or no. This is a yes or no question. So you are going to get the point if you say no, if you don't have any supporting work with it. Part 2 says give a reason for your answer based on the definition of a function and the table of values of f of x. In this case, you need to talk about the definition of a function and the values of f of x. You have to give specific values. So you can't just say there's a repeated x value or repeated y value. You have to give specifically what those are. It also talks about the table of the values of the function of f of x that you're supposed to be talking about. So while it might be helpful to make this table for the inverse, we really need to talk about this table here. So the problem is that we've got these two f of x values that are repeated that we know when they switch are going to become x values for the inverse. So the way that they kind of want us to write this is something like this. Since f of 2 equals 4 and f of 5 equals 4, the function, or f, let's just use their language, an inverse function of f can not be created because each x value, or you might want to say input value, does not have a unique y, or well, we really shouldn't call it a y value because they don't use y anywhere here. A unique f of x value, or you could say output value right there. So in this case, in order for this to work when you switch the x and the y's, each x has to have its own unique y value. You cannot have those repeated y values right there. So this is kind of the language that they really like for you to use to talk about each x value having a unique f of x value. So each input has a unique output for it, so you don't have any repeated outputs there. So this is a type of question they may ask you in Part C, and this is what the answer needs to look like for those.